different answer then?
I got 1/8 x squared.
All right, I love it. 1/8 s squared. Because the only thing that would really change this number right here would become a half, right?
Yeah.
Yeah. All right. Any questions on that so far? Because we're about to ask the billion-dollar calculus question. All right, billion-dollar calculus question. Miss Welko. Part C. Read through that and think about it for a moment. Everybody should be reading through it. It starts a whole nother train of thought. All right, Miss Welko. Why is the change in area not constant, even though the angle is changing at a constant rate? Why would that be?
I do not know.
You do not know. That's fair, right? Because that's kind of weird. What am I asking here? Well, we have what? It looks like this, right? And this is like when it's pi over 6-ish. Nah, it's pi over 3-ish, I guess. It's somewhere between the two, but whatever. And pi over 6 is like this. This same length arms like that, except it'd be like this, wouldn't it? Pi over 6 would look more like that.
Is it because the sides are changing?
Well, the sides lengths are staying the same, right? That's our constant. But when as they get closer together, they would look more and more like this, wouldn't they?
Yeah.
Yeah. Is the area changing here different than the area changing for this, area changing for this? I'll even ask a trickier question. Let's think about, what if it was pi over 2? What's my area become at that point? It nearly says it's nothing. Is that the area? The area is nothing. Well, clearly that's different than when I'm going from here to here where it's getting bigger. Right?
Yeah.
So even though there's a constant change in theta, the area would be all over the place. How fast the area would be changing would be all over the place.
Yeah.
All right. Does that make sense?
Yeah.
All right. We have a 5-minute break right from this second. You may go outside, kiss a tree, take a water break, sing a song, but not over the mic. Get a sandwich. 5 minutes. We're starting in 5 minutes. Make sure you get out of your chair. If you're still sitting in your chair the whole entire time, I'm not going to give you a break next time. Don't think I can't see you. Great choice. We're ready to go. Let's do it. If v equals 4/3 pi r cubed, what do you do?
On the left, v becomes dv over dt.
Love it.
Equals, and then 4/3 pi dr dt 3r squared.
I'm going to tack on a dr dt at the end. That's where we normally put it.
Okay.
Nothing wrong with what you said. It'll work fine. Okay, you said you were stuck? What's dv dt?
Well, okay, then you plug in 800.
I love it.
And you get, and then multiply the 4/3 times the 3.
Love it.
So then it's 800 equals 4r squared pi dr.
What's r? What's r?
What?
What's r?
Oh, 30.
30 squared. Love it. DRDT. Okay.
So then
Whew, that's 900 times 4. It's 3,600, is it? Somebody check me. 9. Yep, that's it.
so DRDT equals 800 over 3,600 pi.
I'm going to cancel those zeros, right?
Yeah.
Can I take it a little farther?
Is that it?
I got 8 over 36, the fraction. Come on now.
But what about do you just leave pi in the equation?
Yeah. No reason to mangle it. How do I get rid of the 8 and the 36, though?
Divide by 4. So
Divide by 4. Whoops. I divide by 4. Don't write down a 4. Equals DRDT. What's my units?
Centimeters.
DT per
Minute.
Love it. Beautiful. That's it. Those of you who decimalize it, which really you should put a crime scene tape when you do that sort of thing, you get 0.071, I think, centimeters per minute. Thank you, Miss Jenkins, although I'm still not sure where you were stuck. Where were you stuck?
I just didn't simplify it.
Oh. All right. Going to the second part, that should be pretty easy at this point. And then we're going to go back and look at 13 while our brains are back at full speed and going to cry a little. Read the question carefully for 13. It's harder than it looks. So this is a weird problem, but I like to draw things first. I'm going to draw it. It says, find the rate of change between the distance between the origin and a moving point on some graph. Now that graph I should be able to sketch pretty easily. What does that graph look like, Miss Flynn?
It's a parabola, like with the thing at 1, like at 1.
Shifted up 1. The thing is called a vertex.
Yeah.
Okay. So the thing is shifted up 1. I like the thing being shifted up 1. And they want to know, it's like I got some random point over here, and they want to know how rate did it, what are you going to call this distance here?
X? No, not X.
Definitely not X. I've already got X's and Y's. You need to pick a different letter. What?
I don't know.
Come on, pick a letter other than X and Y. You can even go Greek if you want to.
We'll do L for like length.
L for length, okay? All right, so that's this L, and this point here is X, Y. Agreed? Whew, here we go. And so what do I know?
You know the equation for the graph, and the dx dt is 2.
dx dt is 2. All right. That's something.
And that's like really all you know.
All you really know. So I need, what am I trying to solve for? What am I trying to solve for?
Rate of change of the distance between.
Which would be what?
Oh, dl over dt.
Yeah, I love it. So, see, it seems how these are only 2 things you know. What's an equation that involves L and X?
Maybe the distance formula?
The distance formula, correct. What is the distance formula?
The square root of x2 minus x1, or
Well, it's going from the origin, isn't it? Well, yeah, let's do
Yeah.
it. X2 minus, I shouldn't correct you. I shouldn't correct you. Keep going.
y2 minus y1 squared.
Love it. Now, this is the difference between 2 points, correct? One of the
Yeah.
points is the origin. So what can I do to simplify my formula just a smidge?
Make one of them 0, 0.
Right, so I'm going to have x squared plus y squared, according to my thing, right?
Yeah.
I might even point out the fact that although you learned the distance formula, some of the rest of us don't know the distance formula. We might instead choose to go, this is x and this is y, and use Pythagoras instead.
Okay.
Either way, that's fine. I mean, there's nothing wrong with distance formula. It's beautiful. It's actually the right choice if you have to remember it. I just didn't expect everybody to remember it. Okay, that has a problem though. We have a y, and we don't want a y. Well, let me back up. What would you do next? I should have said that at all. Just forget I just said it. Strike it from your memory. What would we do next?
Take the derivatives, both sides, maybe.
Take the derivative of both sides. So we go 2L dl dt equals 2x dx dt plus 2y dy dt. Agreed?
Yeah.
All right. So now we start to plug things in. We agreed that we're going to have trouble with x and y. We're just going to leave x and y alone. But I should have everything else, correct? So what is L?
You don't know.
Ew, that's a bad start. That's a really bad start. I'm stuck. But let's go ahead and leave that temporarily. dl dt is what I'm looking for, so that's okay. 2x, what's dx dt?
2.
2, I love that. 2y, what's dy dt?
You don't know that either.
That's a real problem. Okay, so I can't have y in my equation. You got to get it out of there.
Okay.
Let's get it the heck out of there. How do I get it the heck out of there?
I'm not really sure.
Well, we had L squared plus x squared plus, oh, sorry, equals y squared, right?
Yeah.
With the information given, is there any way I can get rid of y and try it in terms of x?
Maybe you could like isolate for y with L and x. Like y equals
Okay.
L squared.
Take a deep breath. Take a deep breath. Look at this. Look at the ceiling. Take a moment. Then reread the problem, and tell me if you can find any way you can relate y and x, so you can get rid of the y.
Oh, the formula.
Yeah, they told us with y, so I could rewrite this y value as, was it x squared plus 1? So this point is also being written as x squared plus 1, couldn't it?
Yeah.
So let's get in here. L squared equals x squared plus 1 squared. Yeah.
Okay, then you take the derivative again.
So now I'm going to take the derivative again. So yes, let's simplify this a smidge before we go crazy and start taking derivatives.
Okay.
I guess we could have used a chain rule that second part, couldn't we? Maybe I'm not simplifying it. I'm simplifying it anyways. Let's just simplify it. I don't want to do this. Okay, so plus x squared plus 2x plus 1. All right. I'm in terms of x and you'll find, distance between 2 points equations being used by real people a lot. But for purposes of this course, that's not fun. Okay?